Okay, all right. So my stream just died, but it's fine. All right. Let's get into it. So, we skipped 2.5 because 2.5 is boring. All right, problem 1. Consider x dot equals minus x plus y and y dot equals minus y. It says show x-axis consists of 3 solution curves. I don't even know what that means. I think what that means is you have the equilibrium, you have three solutions basically on this plane. So you have the x dot equals 0 equals y dot solution. That's 1. Then 2, let's say x is greater than 0. We have another solution. So for x greater than 0, let's pick x equal to 1. We get x dot is equal to minus 1. Let's say x equal to 0, y equal to 0. X equal to 1, y equal to 0. So then this is going to sink. So if we just consider the 1D case of x dot equals minus x, we're going to get our classic, phase or whatever. This is going to be, what do they call it? I don't remember. But you have 0, and then you have f prime of x is equal to minus 1. So then you have this thing like this. So it's a stable fixed point. So since it's a stable fixed point, basically you have 3 curves. You have the curve that for x greater than 0, x goes to so I'm pretty sure that's what they want us to show, but let's just see what they say in the actual textbook for how they present that kind of solution. If y is 0, the system is that. Therefore, any solution that lies in the x-axis tangent, solutions on the negative half approach the origin from the left. Solution on the third is the equilibrium point. Okay, so that's what they meant. So that's good. Okay. Okay, problem 3. Consider x dot equals minus x plus 3y and y dot equals minus 3x, minus y. Okay, so in this case, the question says, verify that y1 of t is equal to e to the minus t sine 3t, e to the minus t cos 3t is a solution. All right, we can do that. That's easy, right? All right, so we got to just take these derivatives. So, dt of e to the t, e to the minus t sine 3t. All right, we're going to just do the product rule. So, let's take this one first. So, f prime g plus g prime f is equal to minus e to the minus t sine 3t plus g prime, which is 3e to the minus t cos 3t. All right, so this is x prime of t. Now we get y dt of e to the minus t cos 3t is equal to y prime of t is equal to, this is just going to be minus e to the minus t cos 3t minus 3e to the minus t sine 3t. Okay, great. So now what we can do is we're just going to do this is equal to minus e to the minus t sine 3t plus 3 times this. And let's see, is that true? So that one's correct because we have this, which is good. And then 3 times e to the minus t cos 3t, that's good. Okay, so now we just get this side, and we get minus 3x is minus 3e to the minus t sine 3t. Okay. So that's good over there. And then we need minus y. All right, cool. So we verified it's a solution. Okay. And you know what? Maybe it's helpful to think about, we have minus 1, 3, minus 3, minus 1. I think that this might be a rotation matrix or something. You know, I can't tell. You know, maybe we should probably look at the vector plot. Let's look at the vector field just real quick, just to see what the heck is going on here. Oh boy. So let's just do this. And we're on existence and uniqueness. Okay. All right. I mean, maybe we could just do a quick little so we're gonna get minus lambda I. So the determinant of this. So first off, we can just get rid of all of this. We verified that that was a solution, but now we can just. All right, so we want to look at the eigenvalues. Okay, so minus 1 minus lambda squared plus 9. So we're going to get minus 1 minus 2, or I can never do this. We get 1 plus 2 lambda plus lambda squared. So this is going to be lambda plus 1. Oh my gosh, wait. Yeah, this is the same as lambda plus 1 squared. Lambda equals minus 1. This is the only. Yeah, of course it is. I mean, you could just look at that. That's obviously true. So we get, this is our eigenvalue. But to find the eigenvector, we're going to get 0, 3, minus 3, 0 times b is equal to 0. And we're trying to solve that. So we could take actually, I don't know if that's right. If we have times 1, 0, we do 1, 0 here. you get 0 minus 0, 0 plus 0, and then minus 3 plus 0. So that's not going to work. So what the hell are the eigenvectors? Okay, so what was the we have eigenvectors of -1, 3, -3, -1. Oh, they're both complex. I still don't really get how. Does matrix vector multiplication work? Surely it does. Okay, great. Wait, I'm so confused. All right, let's see. What did ChatGPT answer? Okay, yeah. So that's kind of what I was imagining, but why can't I? I want to know. This is -1, 3, -3, -1. Just so slow. I don't understand how it's so slow. I mean, I know why. I mean, it has a whole JIT compiler. It's a totally different thing. All right, so they both have imaginary. Okay. I was trying to, I don't know. I don't know what the hell I'm doing. All right, so we did 3. If They will never collide. They will get crazy close together, though, but they'll never collide. Because if they did, then they would have started at the same point. Consider the two drivers given here from exercise. Suppose that at time t equals 0, they start at different points in the parking lot, but at time... Will they ever collide? They will never collide, but they will follow the exact same path. Yep. All right. Number 8. Suppose... Okay, we need to do this. This one in 11. Suppose y1 is a solution of an autonomous system. Show that y2 what is the relationship between the solution curves? They are just offset. They're the the solution curves, what is the relationship? They're exactly the same. They just happen to have a different reference for what you call t0, but they're exactly the same curve since they're autonomous. But A, how did they do this proof? I didn't really understand this thing. So, okay, so two solution curves share some value for two different points. This is going to be t minus... So let's say that this is 0 and this is... Or let's say this is 1 and this is 2. Then this is going to be t minus 1. Let's say this is 1 and this is 2. 1 minus... You're going to get 1... You're going to get t plus 1. So this thing turns y1 into t1. So we consider this. Both y1 and y3 sweep out the same solution curve because y3 is a time translation of y1. On the other hand, dy1 y3 at t2 is equal to I don't understand this chain rule thing. Because we said because this is a constant value, this ends up being just like t minus 1 or something. And so then, yeah, you pick g of t is equal to t. Okay. Then you say, but equal to y1 of t, then. Okay. Okay, great. That makes sense. I just needed to spell it out. But y1 satisfies this. That's true. Okay, we're going to need to go through this pretty detailed. Let's go. It's 2 a.m., bro? And you're watching me? Come on, Z. What the hell, bro? All right, wait. So let me figure this out. Okay, so we have two solutions to we have y1 of t, y2 of t solutions, such that y1 of t1 is equal to y0 is equal to y2 of t2. Okay? Then we want to show that then y2 of t is equal to y1 of t minus t2 minus t1. Okay? So this is the claim here. So how we're going to prove it is you define some y3 of t is equal to y1 of t minus t2 minus t1. Okay? Then since for t equal to t2, we get y3 t2 is equal to y1 of t2 minus t2 minus t1 is equal to y1 of t1. So since these agree at a point, since agree at a point, we have, I mean, since they agree at the point, they must be the same because they're autonomous. But the way that we're going to do it is we're going to show, so the proof outline is 1, show y3 of t is a solution. And the second part is we're going to show that uniqueness implies that y2 of t is the same as y3 of t. Okay, so the first part of this proof is that so first, to show that y3 is a solution, let g of x equal t minus t2 minus t1. Okay, so but notice that g prime is just equal to 1. Okay, so that's the first step. So consider that y3 is really equal to y1 of g of t. So then y3 prime is equal to y1 prime g of t times g prime, but this just goes to 1, so we're good there. So the next step, though, is that y1 prime of g of t is equal to f of y of g of t. Okay, and what they're saying is that since this is y1, but y1 of g, this is equal to f of y3 of t. So why does that show that it's a solution? And what is the definition of f? How does I am from California. Oh, because y of t a solution if it's differentiable and dy dt Okay, so we have a solution. Now, then since, so how did, since y2 of t2 is equal to y3 of t3, then they are the same, and that shows that then, so therefore y2 is just a time shift. All right. Something like that. Something like that. Okay, so let's get back to okay, so it's a problem 8. Suppose y1 of t a solution to y dot dy dt equal to f of y. Okay. So we want to show that y2 of t is equal to y1 t plus t naught is also a solution. Okay, so for all constant, I can just say for all t and r. All right. So so do you do y3 of t is equal to y1 t plus I mean, can't you just say like okay, so we don't know that this is a solution. We just know it's this. So we take y2. So okay, wait, here. We let g of t equal our t plus t0. G prime of t is equal to 1. Okay, so then we take y2 prime is equal to y1 prime of g of t times g prime, which is 1. Okay, but this is equal to dy dt of g of t is equal to f of g of t, but f of g of t is equal to y2 of t. So y2 a solution. Since diffable it's differentiable and y2 dy2 dt is equal to f of of okay. So then the last thing is so it's a solution. We didn't even show that it's the same. So then B says, what is the relation? They must trace the same curve as they collide. At some point y1 of t and y2 of so I feel like that's all you need to say, but whenever it comes to these technical things, I feel like you can always lose points just really easily. So let's just see what exactly how this guy writes it. It's Chat GPT. I want to see how the book does it too. Very well. Okay. How did they do it? I did write it wrong. dy1 g of t is equal to f f of y1 of g of t. Okay, and then we just resubstitute in the time shift. All right. So how did they answer number 8? Yep, exactly the same trajectory. Okay, so okay, that's good. All right, now we need to do 11, right? All right, wait, I wanted to do 9. Suppose y1 and y2 are solutions of an autonomous system where f of y satisfies the hypothesis of the uniqueness theorem. Suppose that um, since they share a point, then they must be the same curve, and therefore they must be a time shift of each other. Yeah, so you just say, so you just do this, but then you say y3 of 1 is equal to y1 of 1 is equal to y2 of 1. Uniqueness then forces y2 equal to y3 for an equivalently. Yeah, so you do this like temporary thing. It's kind of weird. Okay. I didn't get to do 2.7. Shit. Tonight's going to be brutal. All right, so let's just do 11 because I got class. All right, let's do 11. What the hell? So, I mean, the weird thing about this, though, is I don't even know how to solve this. How do you even know? How do you even do this problem, man? Note that dy dt is greater than 0 for all. That's an interesting hint. What is the integral of 1 over x squared respect to x? This doesn't have an integral? Wait, then why didn't my... What the hell? Oh, because it's not called integral, it's called integrate. But how do you solve this system? You do not have very much time. I'm panicking, bro. I'm panicking. I feel like the SIR model one's going to be easy. What could possibly be hard about this? Shit is easy, right? Analytic description. Maybe that I'll cover. Let's see, which problems do we have to do for that one? 3 and 8. However, it takes time. The time it takes to develop a vaccine make it possible to vaccinate everyone before a disease arrives. Which initial conditions guarantee that the change in infection rate is less than 0? Well, if the susceptible if there's no susceptible people, but your answer should be expressed in terms of the parameters of A and B. For given values of A and B, what fraction of a population must be vaccinated to prevent an epidemic? Is there a definition of an epidemic? How does that? Yes, 6 minutes. Okay, wait. Let's just go back to 11. Let's see, how did they answer 11? Y0 is greater than or equal to 1. Wow, that's a hard problem. We need more problems like that. That's crazy hard. Or it's hard just because I would never have thought of doing an inequality argument like that. It's really clever. All right, let me just look at this thing. Okay, and then 8. No. 3 and 8. 3 and 8. Many zombie movies are based on the premise that zombies do not stop infecting. We can model the spread of zombies in a movie by assuming that the zombies become recovered. So zombies grow with the interaction, the mass action, and then they decay with some rate back to here. So if you factor out an S from this, you're going to get alpha I minus gamma times S. So if S is equal to 0, wait, what? Yeah. All right, so the okay, so 0, 0 is clearly an equilibrium point. But then also, let's just assume that all of these are 1. If there's no infected people, okay, so then S equal to anything, or maybe 1. Okay. Okay. All right, we'll probably do a lot of those problems tomorrow. And then we'll also do 2.7 tomorrow. We'll do 2.7, 2.8 in the review exercises tomorrow. And then I'm probably going to do a couple of integrals and just keep hammering stuff. But all right, that's it for today.